coming. Thanks Yaoqi and Outlier team for hosting this awesome event. Today my talk is called More Chains, More Problems. It's about everyone making chains these days. So who is a developer here? Is anyone a developer? Has anyone made a smart contract application? Like on Ethereum or Solana? Has anyone considered making a chain, perhaps? Like anyone deploying a chain through Outlier? I was just talking to Walls from Gate. They just announced a new layer 2. Basically, the issue right now is there's thousands of chains. Every day there's a new chain being announced. And it's just the reality of the situation, right? Why are there good reasons for someone, a developer or a company, to make a new chain instead of deploying an app on Ethereum or Solana? There's actually very good rational reasons to do so. One reason, for instance, is to control the fees, right? So Base is a layer 2 rollup developed by Coinbase. That chain actually brings Coinbase hundreds of thousands of dollars of revenue. I think it's every day that it runs. So if Coinbase had instead deployed an app on Ethereum, all those fees would be going to Ethereum. But since they deployed a chain, all those fees are going to Coinbase. So that's one reason why someone would deploy a rollup, right? Another reason is you might want to control the ordering. Robinhood just announced a layer 2 on Arbitrum. Why is Robinhood making their own chain instead of building on Ethereum, for instance? Well, because one reason is because Robinhood can control the accounts on the chain. They can have full control over that. They can make sure they're all verified users. And they can also control the ordering, which is extremely important for stock trading and for crypto trading. So the reality is there are more and more chains. In fact, with Altlayer, you can basically click a few buttons and you can deploy your chain in just a few minutes. This is just the reality of the situation, and it's just going to continue. More and more developers are going to choose to make their own chains instead of building on existing chains. So that's why we're going to see more and more app chains also. So this is just the reality. I'm not going to say it's a good thing or a bad thing, but there are some problems that it brings, right? There are some problems that it brings. So on the left side, I mentioned that there's a security issue. Most developers are choosing to build rollups. Now the rollups are actually basically controlled by a single sequencer. It's a single server that decides what transactions are included and what the ordering is. That's a single server, and it can obviously be compromised or it can be dishonest. And on the right, you have the liquidity fragmentation issue, which is there's now thousands of chains. There's assets on all these different chains. One asset might be issued on, like USDT might be on like 20, 30 different chains, maybe 50 in the future. You have an NFT on one chain, you have some real world asset on another chain. Liquidity is super fragmented and it's very slow to bridge. So there's these two big problems that are stemming from the reality of there being tons and tons of chains. These two problems are actually very, very interlinked. They're actually basically the same problem. And it's what we're trying to solve at Espresso. The question is, why does a confirmation layer, which is what Espresso is building, why does a base layer for rollups solve both? So yeah, let's talk about the security issue first, right? So as I mentioned, there's the security issue, which is that many of these chains are rollups. They're all run by a single server. And this server can get hacked. Now, rollups, generally, they checkpoint to a base layer, right? They checkpoint to a layer 1 like Ethereum every so often, maybe every few hours. After that settlement occurs on Ethereum, sure, it's locked in. But what happens if you have a single rollup sequencer and it tells you, oh, this transaction got included, and then just a few seconds later, after you've already given a house or given some asset on some other chain, or does everyone understand what I'm saying? Maybe I'm going too fast. But imagine you have like you're buying a house from someone, right? Or you're buying a car, and then you pay them in USDT on some tiny rollup, right? And then the rollup sequencer says, yes, this transaction happened, and then they give you the car, and then the sequencer is suddenly dishonest or gets hacked, and then that transaction is reverted. They say it never happened. Then that person lost both the money and the car. So even if a rollup sequencer is hacked for just 10 minutes, this could cause billions of dollars of damages. There have been many, many devastating hacks of centralized servers in crypto. None that's massive, that's a hack of a sequencer yet, but it's just a centralized server, so when there's money to be made, definitely this will happen. Does everyone know what how bridges work? And has anyone used like a cross or layer 0 to bridge assets from one chain to another? Basically, what's happening there is when you lock assets, when you're trying to move, let's say USDC from one chain to another, what you're doing is you're locking up your USDC on the origin chain, and then on the destination chain, maybe the bridge or the liquidity provider is basically saying, oh, I trust that your USDC is locked on the first chain. I'll give you the USDC on the second chain. I'll basically spot it to you. I'll loan it to you, trusting that it won't revert on the first chain. That's why it costs fees and why it takes time to bridge from one chain to another, right? If you want a faster bridge, you're gonna have to pay more fees because the bridge or the liquidity provider is taking the risk that the origin chain is going to revert. So let's say there's thousands of rollups all connected by a single bridge. And let's say only one rollup, a single rollup has a P% chance of getting hacked. Well, if you have 1,000 rollups and just one can basically be manipulated into reverting transactions, then you can basically, eventually an attacker could potentially even drain all the funds out of the entire bridge. So it's actually very risky. If you have a very interconnected system with thousands of rollups, even if one sequencer is hacked, you could potentially use that to drain a bunch of funds out of the entire bridge. So that goes to my point. Why is security and why is this interoperability problem? Why are they basically the same problem? It basically all comes down to the security of the confirmation. How fast can you be sure that a transaction will never, never be reverted when you're certain that a transaction is truly final? And really, to have something like, eventually to have even synchronous composability, where you can do things on multiple chains atomically at the same time, you really need to be able to have chains communicate instantly. With Espresso, we're trying to lower the communication time from, say, hours with existing rollups for finality to just a second, or even lower than a second next year. This actually is not just about bridging between chains. It's actually, really anything can be thought of as a chain, right? So a rollup is literally just an application that checkpoints to a base layer in crypto. Anything can be turned into a rollup. In fact, like right now you have applications like Hyperliquid or Aster or Lighter that are, like, people criticize them for kind of being centralized, but the reality is any Web2 app can be turned into a rollup. All you need to do is basically make it commit state to a base layer once in a while. An exchange like Binance or Coinbase is basically an application just like a rollup as well. So this is not just about bridging from chain to chain. What I'm trying to say is, let's imagine you're depositing $100 million into Binance on a rollup, and you send the transaction on the rollup, and then you somehow maliciously attack the rollup to revert the transaction. This is exactly why exchanges need to wait, sometimes for some chains, hours, or, like 12 hours for a rollup for a transaction to truly be final. Because let's imagine you try to deposit, let's say like ApeCoin on ApeChain. ApeChain, I think, only checkpoints to Ethereum or to Arbitrum once every several hours. So maybe you're able to trade those assets when you deposit into an exchange, but definitely they're not going to let you withdraw an equivalent amount of value. So this is not just about cross-chain communication, it's about interacting with any type of Web2 application. Basically, you need to have finality, and you need finality fast in order for applications to happen faster. You definitely want to be able to use your assets and bridge your assets, whether it's between chains or from a chain to an exchange, as fast as you can. So again, what are we doing with Espresso? Espresso, we only do one thing. And the only thing we do is we give a very, very fast confirmation. Any data, we give a very, very fast confirmation within about a second that it's final and that the transaction can definitely not be reverted. So We work with any type of rollup, whether it's an optimistic rollup or a ZK rollup. We work with any execution environment, whether it's like an EVM or an SVM or an app chain. We work with any approach to sequencing. So it can be first come, first serve. It can be time boost. It can be anything. We're even working with Off-Chain Labs, the developers of Arbitrum on decentralized time boost. So hopefully that'll get into Arbitrum 1 soon. Espresso is pretty much agnostic to any design of chain you want. All we do is we finalize data. And the reason why Espresso can finalize so fast, first of all, we have a state-of-the-art consensus, but the key thing is we literally only finalize data. We do no execution, and as a result, the nodes in the network also do not even need to download the entire, all the data. The nodes in Espresso only need to download a small piece of each transaction. We use something called, similar to like erasure coding, but all Espresso does is finalize data. We do no execution, and that's why we go so fast. Espresso is actually optimizing for something called optimistic responsiveness. This is a property of consensus that is completely disjoint from dynamic availability. So for Ethereum, right, Ethereum's consensus is called Gasper. People think, maybe Ethereum has a block time of 12 seconds, but the finality time is actually 15 minutes. It's about 15 minutes. So when you send an Ethereum transaction, you actually can't be 100% sure that the transaction will not be reverted until about 15 minutes. Obviously, Ethereum has a lot of economic security, and it's super big, so it's probably fine to just wait 20 seconds. But Ethereum has this property called dynamic availability, which means it's very World War III resistant. Means even if 90% of the nodes suddenly go down, Ethereum's still going to run. Obviously, Espresso has some downsides, right? Espresso's consensus is called hotshot. If 90% of the nodes were to go down, Espresso would just stop. But the good thing is, in good conditions, Espresso can run as fast as possible, almost as close as the performance of a centralized sequencer. So, and it's been proven a consensus protocol cannot have both. So you can actually think of Espresso as like a sort of, if you combine it with something like EigenLayer, in fact, with restaking, you can actually have the same set of physical nodes and the same economic security, but just with completely different properties. So yeah, what we're trying to do here with Espresso is Web 2 performance, but with Web 3 security. That's really what we're trying to do. Right now, Espresso is already on mainnet, actually. We have been live on mainnet since for almost a year now. We support almost 10 rollups on mainnet right now, including ApeChain actually just integrated Bored Ape's chain last week, which is pretty cool. It's run by around 20 institutional and community validators. So Figment, Blockdaemon, Kudasai, et cetera. And we're very excited that in about 2 months, we will upgrade to proof of stake, so fully decentralized. So yeah, keep an eye out for that. Again, all Espresso does is confirmations. Espresso is compatible with any execution. You can use any DA. You can also use Espresso for decentralized sequencing, but in fact, most of the chains that use Espresso now do not. They are only using Espresso for very, very fast confirmations. And you can also settle anywhere. So yeah, thank you for listening. And yeah, if you're building a chain, we would definitely love to work together.